like incineration. You cannot do that in England. They are very reluctant. Australia, the US also not very much. So that's a little bit to discuss. They still have also in Japan discussion. Now, but the energy recovery from incinerator is relatively low. Not very much if we are talking about, and this is sometimes the recovery rates for electricity is very low, and the reason is also that the heat that is produced is not used. And this is a pity. Now in Europe, the new incinerators that you build, you have to use also the heat. That's a challenge. Now new developments, an incinerator, a higher steam, or that you get perhaps to 30% utilization, which is quite a big step. And as I said, heat utilization is a thing because you produce more heat than electricity, and from that point of view, that's a big challenge what you do. Now, I think we will see less mass burning in the future, because, as I said, you still are limited with that, and it is difficult for these big incinerators to have heat utilization. So probably we will see more RDF. That means we produce a fuel from waste. Now, heat utilization, there are a couple of possibilities. You can also make from heat cool. Yeah, this is also possible. You can use the heat to cool the buildings. Also for Singapore, it would be very interesting to do that. But you have to have the user pretty close, because if you build the isolated pipes for transportation, very expensive. Heat storage is something. This is in the research area, and you have a kind of ORC process where you evaporate silicon, and with that you can drive a turbine. This is something that boils at lower temperatures, and then you can use the gas. So there is need for further development. Now, if we are talking about RDF, that means a refuse-derived fuel. That we take the refuse and we separate very simple, actually, kind of sieving. Now you see here the different mesh sizes, yeah, the different diameters of meshes. You use different mesh sizes, and you see here the weight. So, for example, if you have mesh size of 100 millimeters, 10 centimeters, yeah, and then you can see that at a mesh size of the underflow is about of paper, yeah, would be about 40%, and you can recover with 100 about 60% of the paper. So very simple thing, and this is how it is done. Just some sieving, perhaps some wind blowing systems in order to separate out the material. And this is how this material looks like. It's a fluffy-like material, and this has a relatively uniform heating value, and this can be used also in smaller decentral plants for energy production. Of course, you have to meet also the emission standards like normal incinerators. Yeah. And I think, actually, if you, in the future, that you use also for pyrolysis or for smaller plants, these kind of fuel, that would be good. And normally, in the residual waste, and you see that here in the underflow, you still have organic material, so that you can still burn the residual waste in mass burners, but it will be much less, and you have on the other side a high value fuel. So I think this is something to think about. It is the future. It is done in some plants, but you can also do co-fire. Yeah, I think I have it here. You can also do some co-firing. You can do that in, as we said, fluidized bed incinerators, which are more effective than the others. So you have a better quality material actually to use that, and actually also gasification, what we are now talking more about. You need a good homogeneous fuel, otherwise it will be difficult to actually get a good operating of those kind of things. I think this is essential. You see tendency co-firing in coal power plants, they did that. You have to take care of corrosion. In cement kilns it is used, fluidized bed incinerators I showed you here. And it is interesting also that you build smaller plants adjacent to big plants that need the energy. For example, a car manufacturer, you build a small RDF plant there, or a paper mill, you build that there because they need a lot of energy and you can use the same. So, a lot of possibilities if you have that. Now, pyrolysis gasification is something that should be further investigated. I think there is a potential for that, but more for smaller plants with a more homogeneous fuel. I think this is actually what we have to see. Landfill is also still a resource. One thing is landfill mining. If it makes sense, there's discussion all over if it makes sense to excavate the waste from the landfill and, you know, separate out the materials for utilization. There are pros and cons. This will be investigated and we will know more into this subject. But also the landfill itself can be used actually as to build houses on or to build industry on the landfill. I think we will see that more and more because the landfills were in the past built outside the cities, but the cities grow. Now they are inside the cities, and the ground, the property becomes more and more valuable. So I think this is something. But if you want to do that, then actually we have also produced a kind of incineration process. That means we aerate old landfills, we put air in, and then the landfill becomes more inert, no biological activity anymore, and then actually you can use that actually to do that. Now, the last part of my presentation will be decentral system. This is something we have big research project at our research center RTC at NTU, and it is discussed more and more all over the world. Now, is it good if you have huge wastewater treatment plant central with huge sewer systems, or may it be an option that you have smaller units with smaller pipe systems and use actually and treat and use the waste and the wastewater where it is produced and gain materials and energy out of that. That's the idea out of that. Now here you can see that you have water income in your house, water, rainwater, and then what you produce in your house is yellow water, this is urine, gray water, this is from shower, washing machines and so on. And you have also black water, all the side, brown water, this is actually the filter. So these are the substrates that you produce in a house. And so what you do with that? You know, normally this goes all into the sewer system in the mixed way. But there's the possibility also to use the gray water and reuse that as service water for flushing the toilet, for net cleaning, forever, for the washing machine and so on. That's the possibility that you have. Or you can then use the urine to make actually a kind of fertilizer out of that, precipitate out phosphorus and nitrogen, and use that actually as a fertilizer. Or you can use the black water together with your kitchen waste, organic kitchen waste all together, make anaerobic digestion and make some energy out of that, and also kind of organic material, compost that you can also use on land. This is a little bit theoretical, but it is the concept, and now we are in that position that we say, okay, how can we implement that? And there is not one solution, there are different kinds of solutions, how you could actually do that in different areas. So what we develop actually is different tools that we can use in order to make tailor-made solutions. Yeah. So can do that in living quarters, but also in big hotels, skyscrapers. So units that are a little bit enclosed, interesting for big hotels in remote areas where you don't have sewer systems and so on. And then you can do that differently. We are now working on also a vacuum system, small vacuum systems, for transportation of the black water and yellow and brown water. And so from that point of view, I think it's an interesting approach that should be further developed. Those kind of systems normally exist already. So you have vacuum systems, you know that from the airplanes and from the trains now. Those kind of things you can have also in villages. So this is not a big problem. Now if you look at this, looks a little bit confusing, but if you just look from the separation toilet, you can actually make out an anaerobic digestion together with the kitchen waste, biogas. You dewater that and make compost out of that. This is one route. Then you have the gray water separately collected. You could, for example, use membrane technology, make very nice usable water. The concentrate goes back into the anaerobic digestion. From the urine, you can make phosphate and so on. So there are possibilities to do that, and we investigate that and see. I mean, in the beginning it's expensive and so on, but I think it's something to do that. Another concept is here, which is more technological, which is interesting too, that you have mixed toilet. You say, okay, we don't do the separation and source because we have already a system in place, but we add the kitchen waste to that, and then we have anaerobic digestion, then we have a kind of further aerobic treatment, so we further treat that by blowing air into the system in order to reduce the residual organics, and then we dry the material, and then we have a kind of compost plant. Another possibility. You just out of your system, you have this small pellet that you put out of the system. So you don't have big sewer systems, you don't have organic waste collection system. And the grey water again with membrane technology, as we use that for seawater desalination, it's the same technology. And then we make potable water out of that, and we can integrate the whole system. Now, the trends, just to sum up, the trends in solid waste management, as I see that, also technology development, is this automatic separation system that will change, actually use that as fuel. Improvement of the ash quality from the bottom ash from the incinerators. You always have to keep in mind, by weight, you still produce 20-25% of your waste that goes into an incinerator. You get bottom ashes, and what you do with the bottom ashes. So how to use that, I think that's a challenge we have to do. We will see probably more pilots, gasification, plasma. We have read probably in the newspaper that the big airlines use a plasma technology to make the fuel for the airplanes from waste. We will see how it will work. British Airways has said that. I think also an Australian company. So we will see. I'm curious how it works, and I think we will also see more decentral plants. Now the overall concept, and this is actually the last picture here, we have waste avoidance for the waste management. We have then the municipal solid waste that we have to deal with. Then we have the separate collection. And after separate collection, we have the bio-waste, we have paper, plastic, and so on. We get the residual waste, as we call that. And normally it goes to mass burning incineration, but we could also have a separation step, make RDF out of that, the refuse derived fuel for thermal utilization. The ashes can be reused. At the separation step, we can also still put some recyclable materials out, and then we have some hazardous waste from the off-gas treatment, some fly ash, and some inert waste. The organic, separate collected organic waste, we do anaerobic digestion biogas, and we do compost. This is actually some research needs that we have, and the question is, at the end of the day, is it actually an illusion, or it is a concrete target, or is that a philosophy, the zero waste society that very often people promote or advertise? I think it's a philosophy, it's a target. We will never reach it, but we should aim for that. Thank you very much.